Hello students, myself Rakhi, Assistant Professor in the Department of Electronics and Communication Engineering, AB Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of optical communication, I am going to deliver before you optical receiver. So, in this particular contest, the content which shall be covered in this particular lecture are optical receiver design, digital signal transmission, error sources in optical receiver, probability of error or BER, computation of bit error rate, receiver sensitivity and quantum limit. So, before proceeding for the lecture, just I want to know what are the basic thing in the optical communication system. Whenever we talk about the optical communication, it is already known to you that we require the transmitter, we require the transmitting medium and the receiver one. In the optical communication also, we have a transmitter which comprises of the transmitting medium of and also the optical sources etc. Then the transmitting medium which comprises of our optical fiber, and here comes the optical receiver. So, in any receiver design in optical receiver design, the purpose of the receiver is to convert the optical signal into the electrical tone. First function which has to be performed by the receiver is that to convert the optical signal which is coming from the optical fiber into the electrical signal, because the further analysis of the signal is in the electrical domain only. So, first purpose is to convert optical signal into the electrical one. Second one is to recover data which is sent by the sender, because in between we have got the signal undergone through various type of attenuation etc. Sometimes the message is also in the coded form and in other form also. So, at the receiver section we have to recover the data which has been sent by the sender. So, the receiver first must detect. The first function which is performed by the receiver is to detect weak signal, because of course we know the signal which is received at the receiver section of in the optical system is a very weak signal. Its magnitude is very much less. That is why it is called a weak signal. The first is to detect this weak signal. So, here what we are seeing that optical signal is detected by the photodiode. So, what the photodiode will do? Photodiode will convert this optical signal into the electrical one. Okay. Then a pre-amplifier, because the signal which is received at this end is a very weak signal. So, amplifier is added. This is called the pre-amplifier because it is added prior to the another circuit. That is why it is called the pre one. So, pre-amplifier, of course, what the amplifier will do? Amplifier will amplify the signal. Then comes another amplifier. Then here comes the filter section. Here comes the gain control, because we have to maintain the gain. Then filter function is to filter out the some noises etc. which are providing in the indulge into the signal during this propagation process. Then comes the decision circuit. Decision circuit basically decide which signal has to be received and which signal has not to receive. So, this decision is made by this decision circuit, and then the final data is recovered. So, again I am repeating you, first the signal, optical signal is received and that signal is very weak, but photodiode converts that optical signal into the electrical one for the further analysis. Then an amplifier is used for the amplification purpose, then a filter for removing some noises etc. Then a decision circuit. Decision circuit plays a very important role, because that decide which signal has to be received or which signal has to be discarded. So, then the decision. So, these are the basic structure of our receiver. Now, again the same thing is said here. A photodetector converting the optical energy emerging from the end of the fiber into the electrical one, and this function is provided by our photodetector or the photodiode. The next one is the next section of the receiver is amplifier section, which is used for amplifying the signal. The last one is the signal processing circuit, which comprises of the electronic circuit following the receiver amplifier at the end also, that is at the end amplifier is called as the post amplifier. So, these are the signal processing circuit, or we can say it as a data recovery circuit, and also we called it as the decision making circuit. All plays the same role. Now, there is one of the example of a digital signal transmission from the initial phase, that is from the transmitter section, and then to at the receiver one. So, here are the different pulses, for example, and which is time period of TB. So, here it is shown 1 0 1, this is a electrical input pulse. So, what we have to do if we have a optical signal transmission, we are talking here only about the optical one. So, we have to convert this electrical signal into the optical one. So, LED or laser has been used. What the function of LED or laser? The function of LED or laser is to convert the electrical signal into the optical one, and it is doing the same. So, now the signal is again the 1 0 1 only, but now it is a optical power pulse. It is in the form of a optical signal. Now, when it is converted into the optical signal, it gets transmitted into the optical fiber. So, already known to you that when it passes through the optical fiber, it gets attenuated at the various sections. So, during the attenuated process, our pulse get distorted, of course, it get broadened, various type of attenuation process, broadening process already we have discussed when we are discussing about the attenuation, which is a part of a unit 2 of your syllabus. So, the signal get distorted, but it is get broadened in this form, but again 1 0 1 signal get attenuated because you are seeing that the shape changes. Then now comes the, now this signal has to reach the receiver section, and when it receives the receiver section, it first get encountered with the photodiode, and we have already discussed about the different types of photodiode, which is the pin or the avalanche diode. So, what is the function of this photodiode? The function is to convert the optical signal into the electrical signal back for the further processing. So, now 1 0 1, the signal remains the same, but of course, in the distorted form, but now it is in a electrical current pulse, of course, containing the noise also. Then comes the amplifier and the filter. So, now when the amplifier, of course, this signal is of weak signal. So, now when it is amplified, you are able to see that its amplitude get enhanced, but again 1 0 1. Now comes the decision circuit and the pulse generator. So, what is the function of a decision circuit? Decision circuit requires a threshold value. So, we in decision making circuit, we firstly of all take a threshold value. If the signal which is coming here is above that threshold value, then it is taken as 1, and if the signal which is reaching here is below the threshold value, it is taken at 0. So, of course, this one is above the threshold value, we are considering here the ideal condition. So, we are getting the 1 pulse, we are transmitting the 1 signal, and below the threshold value we are transmitting the 0, above the threshold value we are transmitting the 1. So, the signal which is get distorted here get accurate at this point of time. So, this is, or that is why it is called as the data recovery process. We have already seen that This is called as the data recovery, because data is now recovered. Whatever attenuation or something has gone through under the process of propagation, it is now get recovered here. Now, you can use the signal processing equipment for whatever purpose you want this signal to be used. So, this is the complete flow chart of a digital signal transmitter. So, whenever it is asked in your question that describe the optical digital signal transmission, so you can completely draw this one and one by one keep on explaining the different parts. Now, continued in this, of course, the same thing what I have told you is written here in the subjective form. The transmission signal is a two-level binary data, that is our 1 and 0, consisting of either a 0 or a 1 in a time slot that is shown here, that is equal to TB. This time slot is also referred to as the bit period. Electrically, there are many ways of sending a given digital message. So, one of the simplest technique is used here, which is our amplitude shift keying or the ASK, wherein a voltage level is sandwiched between two values which are generally on and off. So, on means 1 and off means 0. When a 1 is sent, that means presence of optical signal. A voltage pulse of duration TB occurs, whereas for 0, that is absence of optical signal, a voltage remain at its 0 level. The function which is already told to you in this figure, that function of a LED is to convert the electrical signal into optical one. Optical signal get coupled with the fiber and it is get attenuated during its propagation process. Reaching the receiver, what is happening? That it get interact with the Blanke photodiode or a PIN photodiode and get converted into the electrical signal back. Then it encountered with the amplifier for the amplification of the signal, and then it get encountered with the decision making circuit. And when already told to you in this figure also that a threshold value, decision making circuit has got a threshold value. So, compares the signal, decision making circuit compares the signal which is received at each time slot with a certain reference voltage which is known as the threshold voltage, and if the received signal is greater than the threshold voltage, 1 is received, and if the received signal is below the threshold voltage, 0 is received. The same thing which is depicted in the diagram is written here in the form of words. Now, which are there are different sources of error in the optical receiver. So, when the photodetector having a gain m, when a photon stream strike here, so here got a photo detection quantum noise which fluctuates in the form of a Poisson distribution. About that we have already discussed in the previous lectures when we are talking about the noises in the receiver part, the noises in the photodiode. Then when this photon stream reaches the photodetector, it can get encountered with the bulk dark current. I think it is already known to you that what is dark current. When no signal is given to the photodetector, but it is transmitting some sort of electrical signal, then it is called as the dark current. Again, when no photon is incident on the photodetector, but it is transmitting some sort of electrical signal, then it is called as the dark current. Again, at the photodetector level, it get encountered with the surface leakage current and statistical gain fluctuation for avalanche photodiode. And again, we are also have a get encountered with the thermal noise which depends upon the resistance. Now, amplifier also gives some sort of a noise. So, these are the different type of noises which get encountered at the receiver section at the different levels, and this mainly contributes to the errors in the optical receiver. That's why it is called as the error sources in optical receiver. Now, we have gone through the errors, reason for the errors, but we have to calculate the error, because at last we have to make our signal error free. So, the probability of error and the bit error rate is discussed here. So, what is meant by the probability of error first? Probability of error is defined as the measuring the rate of error occurrence in a digital data stream. So, what is the probability of error? Of course, in general terms also probability means ki in what probabilities in what proportion something is occurring with respect to a total. So, it is also the same thing. It is defined as the measuring the rate of error as compared to the digital error, signal that is transmitted. So, what in simple layman's language we can say that जितना signal error हो रहा है signal में upon the total signal which we are transmitting, that is called the probability of error. So, a simple approach is to define it is to divide the number any, that is error occurring over a certain time interval by the NT, that is pulses during this interval, that is called the our error rate. That is why it is called number of errors. If we are saying, for example, for time interval T1, the number of errors is any, and during that interval only T interval, number of pulses transmitted. That is called the BER, or it is bit error rate, and it defines the probability of error. Number of signal transmitted, it also given in the form of a BT, where B is equal to 1 by T, TB is the bit rate. So, number of pulses transmitted can be written in this form also, BT, where B is equal to 1 by TB, that is bit rate, pulse transmission rate. Normal, when we talk about the error rate, so error rate is expressed by the number such as 10 to the power of 9. What does this 10 to the power of minus 9 indicate? One error occur for every billion pulse sent. It indicates one error occur for every billion pulse sent. So, what will be the, in optical fiber communication system, what will be the rate of a typical error is 10 to the power of 9 to 10 to the power of 12. This is the normal range of error, that is our BER. Now, here we am going to compute before you little bit about the bit error rate. So, whenever we talk about the bit error rate, in the digital system we are talking here. So, always digital optical transmission. Digital optical transmission. So, by knowing the probability distribution of the signal at the equalizer output. So, what is here? Probability, that the first one is what is here? In when we talk about the computation of a bit of error, what is first thing which comes to our mind? That we are transmitting the signal in the form of a 1 and 0 only. But what will happen that if we are transmitting the one signal at the from the sender end, but at the receiver end we are getting the 0, then this is the error. And again, when from the sender end we are transmitting the 0, but at the receiver end we are getting the 1, this is also called as error. So, by taking this two thing in consideration, we are calculating the here bit error rate. So, probability that the equalizer output voltage is less than V when a pulse 1 is sent. So, already we have seen that in the decision making circuit, we compare the incoming signal with some threshold value. If the signal which is coming is above that threshold value, then that is called the, we receive the 1 at the output. And if the incoming signal is below that threshold value, we are getting 0 at the output, and this threshold value is set in between the 0 and 1, or we can say in between the maximum one and the lower one. So, that is why here it is said the probability the equalizer output voltage is less than V, that means less than some threshold value. So, you can easily say if it is less than threshold value, then at output we will get 0, but what pulse has been sent? The pulse that has been sent is 1. So, if we are sending the 1, in ideal condition what we will get? At the output also we will get 1, but here we are getting 0. That is why minus infinity to V, range is minus infinity to V P y upon 1. This 1 indicates basically our transmitting signal 1, and in some book also you will get 0 by 1, or here also 0. That means we are sending 1 and we are receiving 0, because here limit you can easily see minus infinity to V, that means the value which we are getting is less than the threshold value. Same here also, probability the output voltage exceed V. When we are exceeding the V, that means in idea we will have to get 1, we will get 1. So, we will get 1, but what we are transmitting? We are transmitting 0, and if it is greater than V, so what will be the range? Of course, if we are V is the threshold, so V to infinity. So, limit is V to infinity, we are transmitting 0 and we are getting 1 here. So, here it is written here P y by x is the probability that the output voltage is y given that x was transmitted. So, output voltage 0 when 1 is transmitted, output voltage 1 when 0 is transmitted, and it is also shown here in the graph that P y upon 1, that means it is 1 by 1, that is we are transmitting 1 and we are receiving 1, but in the same, this is the threshold value, this is the threshold voltage which is given by V here, V not V, that indicates what does it mean? That we are transmitting 0, but we are getting 1. So, this is the error, and it is what? P y 0, 0 by 0, that is we are transmitting 0 and we are receiving 0. So, it is, but this shaded region is we are transmitting 1, but we are getting 0. So, this basically this shaded one is our error. So, if the threshold voltage is VTH, then the error probability P is calculated by this one formula A P1, and what is A? A and B are the probability that either a 1 or 0 occurs respectively. So, same thing here, when we are transmitting 1 but we are getting 0, and when we are transmitting 0 and we are getting 1. So, A and B are defined on that basis. If the system is unbiased with equal probability of 1 and 0, in that case A is equal to B equal to 0.5. So, on that basis the final expression for the bit error rate, probability of bit error rate is calculated, which is given by this formula. Now, the receiver sensitivity. So, when we called about the sensitivity basically means what? How easily a device can detect a minimum to minimum signal. So, let us see the receiver sensitivity in the optical communication defines the same thing. To achieve a desired BER at a given data rate, a specific minimum, the minimum terms comes, sensitivity requires the minimum one, minimum average optical power level must arrive at the photodetector. The value of this minimum power level is called the receiver sensitivity. So, I can easily say that you have not to remember this definition word, but the sensitivity definition is same as the other device sensitivity, that minimum power level, value of this minimum power level, optical power level that arrive at the photodetector to achieve a desired BER, that is our sensitivity. A common method of defining the receiver sensitivity is an average optical power AVG in dBm, because always I used to say to you that the value power we are getting at the receiver section at the photodetector input is very low, very less. That is why it is measured in the dBm. The receiver sensitivity gives a measure of the minimum average power needed to maintain BER at a specific data rate. Here is a sensitivity of some of the device, some of the commonly used photodetector is given, that is pin diode and a blanket. You can easily see what is going on between the relationship between the sensitivity and the bit rate, because it goes in parallel with each other. Receiver sensitivity gives the measure of minimum average optical power needed to maintain a maximum BER, which is our worst case. So, just look at this graph which gives our relationship between the sensitivity and the bit error rate for the two commonly used photodetector. Now comes the quantum limit. So, quantum limit is another one of the most important parameter of the receiver section, just as the bit error rate, noise margin, signal to noise ratio and our sensitivity. This is also one of the important parameter for calculating the performance of a receiver. It is assumed by, it is calculated by what? By assuming zero dark current. Again I am repeating the what is the dark current? When electrical signal is received when no optical signal is incident on the our photodetector, then we will get that the signal, electrical signal which is generated is called as the dark current. But here we are assuming, for quantum limit calculation, we are assuming that the zero dark current condition. It is a minimum received optical power required for a specific bit error performance in a digital system. So, this is a minimum received optical power for a specific bit error performance in a digital system. So, we can easily say that is related to the our sensitivity. This minimum received power is known as the quantum limit by assuming all the parameters to be ideal. That is why it is we had taken the zero dark current. Sensitivity of most receiver is around what? 20 dB higher than the quantum limit, because of the various non-linear distortion and the noise effect on the transmission link. So, what we have learned through this line, the sensitivities of a receiver is higher, 20 dB higher than the quantum limit, but both are related to each other. When specifying the quantum limit, distinguish between the average power and peak power quantum limit based on the peak power. So, here is a formula for calculating the whatever quantum limit. Assuming that an optical pulse of energy E falls on the photodetector in a time interval tau, this can only be interpreted by the receiver as a zero pulse if no electron hole pair are generated with the pulse present. The probability that no n is equal to 0 electrons are emitted in a time interval tau, 0 electrons are emitted, probability it is given by e to the power minus n. We can find the minimum energy E required for a specific wavelength. So, in this particular lecture what we have studied? We have studied the receiver section of the optical communication and the different parameters which are decide the performance of a receiver. Thank you for today's lecture.